Today we want to talk about integration by parts, and we're going to start by backing up to one that we know. This is how we want to know this information. The integral of natural log of x dx is x ln x minus x plus c. That's the best way to know this information. But it has to come from a place of knowing where this came from. So we want to make sure that we do know that we integrated natural log of x using parts, and we put natural log of x in the u place. And then all that was left for the dv was the dx. We have to remember that we did this because we didn't at the time know the antiderivative of natural log of x. The reason that we want to know the context where we get x ln x minus x from is that we can easily adapt this. Because notice that just having dv equal 1 times dx, we're thinking of this as dv equals x to the 0 times dx. And we also know that if we have some power of x with the natural log of x, if we have, say, x to the 8th natural log of x dx, we know that all that happened is the exponent went up by 1 and then started making some fractions. So we know that with x to the 8th, we're going to get 1/9 x to the 9th natural log of x minus 181 x to the 9th plus c. This would be the best way to find this antiderivative. Now, this has to come from a place where we understand how it works. We have to know that this happened from integration by parts, so that we're not just like remembering stuff, but we actually know stuff. So we know this happened because we did the same thing as when we integrated just natural log of x. We put natural log of x in the derivative location because when we take its derivative, we end up with a rational function. That switches form. And for dv, we put an x to the 8th, and that's where all these 9s and x to the 9s come from. We want to know where these things came from, not just remember the result. We don't want to have to write down all the stuff that went into making the result, but we want to know where things come from. We want to recognize what made this such a big deal. The derivative of natural log of x is 1 over x. So now when I combine that rational function with the polynomial function, stuff can cancel out. Things simplify. Multiple levels of what's going on here. First, knowing the result, probably the least important one, but first, knowing the result. Second, knowing how to get the results. Third, appreciating the weirdness that goes on in getting this result, that the natural log of x through the derivative becomes 1 over x. We go from this weird transcendental function to a nice rational function. The same thing happened in arctangent and arcsine. Our secondary integral didn't simplify as easily, but the derivative of arctangent is 1 over 1 plus x squared. So we integrate by substitution. The derivative of arcsine is 1 over the square root of 1 minus x squared. So our secondary integral was substitution. But this reveals something else that I said you should only try if you're brave, but it does reveal an interesting parts trick. Let's look at this and deliberately get this wrong. Let's deliberately make things difficult by stubbornly putting our polynomial in the derivative location. Because at this point in our mathematical careers, we now know what the antiderivative of natural log of x is. And that's my one rule for deciding what's your dv. Now, this is going to get messy, but some good will come of it. Let's put this together in the parts formula and see what happens. So our parts formula is going to be uv minus the integral of v times du. And this is not going to look fun, but we're going to have x to the 8 times x ln x minus x. Since I'm multiplying, and one of my factors has many terms, I will need parentheses. Minus the integral of v times du. I'm going to write the 8x to the 7th part first because I like that to go in front of my parentheses. Now we're going to break our rule of making things worse in our secondary integral because things aren't quite as bad. It's just hard to see because we have to do some shenanigans. But here we got uv minus the integral of v times du. And we look at our secondary integral and we're like, oh, dude, this is kind of worse than what we started with. But notice that our secondary integral has 2 factors in it. Let's put those together. We'll get 2 terms and break those 2 terms into 2 different integrals. First, I want to distribute up here. So from this first one, we're going to get x to the 9th natural log of x minus x to the 9th. Now, in my integral, I'm also going to distribute. So my integral in here is going to be the integral of 8x to the 8 natural log of x minus 8x to the 8. Now I'm going to break this into 2 different integrals. One of my first integral is going to be minus an integral of 8x to the 8th natural log of x. So we're going to have one integral here. This minus is going to have to come in and make a plus. So I use the distributive property and I split this into 2 separate integrals. Because integration is a linear operator, I can do things a term at a time. I can integrate a term at a time. So at this point, we see some things starting to happen. First of all, we got the x to the 9th natural log of x minus an x to the 9th. So we got that structure. The coefficients are off, though. But look at what we have over here. This first integral is just 8 copies of what we started with. This second integral is pretty simple. So let's write down what we got. We got this integral out here is going to be plus 8 times x to the 8. So we're going to add one of the exponents, divide by the new exponent. It's going to be plus 8/9 x to the 9th. This middle integral is 8 copies of what we're looking for. So this middle integral is 8 copies of what we're looking for, or minus 8 copies of the integral of x to the 8, natural log of x dx. So that part of the integral, or that part of the secondary integral, is just negative 8 copies of the integral that we're looking for. Remember, our secondary integral shouldn't be any worse. But we don't actually have to make it better if we get a term that's going to be the same as what we started with. Because now I'm just going to add 8 copies of the integral that I'm looking for to both sides. I'm going to add 8 copies of this integral to both sides to cancel it out over here, and it'll show up as 8. Oops, sorry, there's one over there already. 9 times the integral of x to the 8, natural log of x to x. I've got x to the 9th, natural log of x, minus x to the 9th, plus 8/9 x to the 9th is minus 1/9 x to the 9th. So 9 copies of the integral I'm looking for is x to the 9th, natural log of x, minus 1/9 x to the 9th. So now all we have to do is divide by 9. Take an arbitrary constant and divide it by 9, we just get some other arbitrary constant. So we'll just continue to calling it an arbitrary constant. So we get the result that we knew we were going to get. We got the result that we knew we were supposed to get. dv has to be something that you can integrate. In this case, at this point, we can integrate natural log of x. It's not always something that we're going to want to do, but we did find a cool trick when we did switch them around. As part of our secondary integral, we didn't get something that was worse. We got something that was exactly the same as the thing that we're looking for. So we should gather them up and then just divide by the coefficients. That's a pretty cool maneuver. Any questions? How's everybody okay? At this point, the most important thing that you want to walk away from as students is to know that the integral of x to the eighth natural log of x dx is 1/9 x to the ninth natural log of x minus 1/81, 1/81 times x to the ninth plus c. Be able to write that down first. When I say show your calculations should amount to just like writing this down. You don't need calculations, you can add 1. That's all you need to do. Add 1 and be able to square stuff. That's what I want you to write down. That's as much as I want you to write down in this scenario. I want you to know how to do that by parts in the standard way. U is ln x, dv is x to the eighth. But more importantly, I want you to be able to get the result. How's everybody okay? Next semester, when you're in Calc 2, and I'm still talking about integration by parts, and you're wondering, like, dude, didn't we do integration by parts last semester? And they're going, yeah, and here we are doing it again. You're not going to be fooled when I say, do we know the integral of natural log of x? Some of your colleagues will be all 1/x. You're like, oh, no, that is the derivative. It's x ln x minus x. And people go, oh, they have secret calculus knowledge. And you're like, oh, ha, 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 ha. You cannot defeat my secret calculus knowledge. Any questions? Comments? Snide remarks? How's everybody okay? Now, if you're worried about like being able to replicate this work on like some kind of quiz or test or something like that, don't worry about that if you're in my class. I don't know what your Calc 2 teacher is going to do. They might give you like e to the 3x sine of 5x and expect you to do these kind of shenanigans. Be aware that these kind of shenanigans exist. And then if you know you're going to be called upon to do said shenanigans, prepare for it. Don't spend any time at this point worrying about the shenanigans. Does that make sense? This, in my mind, falls in the category of niche questions. And a niche question is just one step on the legit side of a trick question. Like there's a dividing line between legit questions and trick questions. Trick questions should never appear on any assessment of your abilities. That makes sense? Never put trick questions given by teachers outside of the context of just for shits and giggles is bullshit. If there's a test and there is a trick question worth points, that teacher has fucked up and they're being bad. I don't know if you would be brave enough to call them out on it. That'd be a pretty bold move. But if you don't want to do that yourself, refer them to me. And I will happily call them on their bullshit. Any questions? This is not to say I won't ask trick questions. I just won't make them worth any points that I wasn't going to give you anyway. You know what I mean? Like I come up with 19 questions and I just can't come up with 20th question. And I want the test to be worth 20 points. I might come up with one BS question that you can't get wrong. I just leave it, unless you leave it blank, because one of the rules is if you have, especially if you have a multiple choice test, you have to answer it. I don't care if they're like, oh, there's a penalty for guessing. Bullshit, it's not a penalty for guessing. They're just trying to protect their product. The test. Do a probability analysis of your penalty for guessing. Is everybody familiar with the penalties for guessing? Have I gone over this in this class? What is the penalty for guessing? So on some standardized tests, there'll be multiple choice, and the test makers don't want you to guess. So they give you negative points for getting things wrong. It's not a penalty for guessing because they don't know if you guessed or not. They don't know that. but they do know if you get something wrong. So here's how the penalty for guessing works. There's 5 choices, A, B, C, D, and E. If you get the answer correct, you get +1. If you leave it blank, you get 0. If you get it wrong, you lose -1/4 of a point. That's the penalty for, quote, guessing. They don't want you to guess.
Yeah, debate of any completed.
Correct. So like if you have to fill up the bars, if there are achievements that you have to do and you'll keep playing, twice the number of hours is normal just to get that last stupid achievement. Because the last achievement is like, I'll complete the game 20 times for no reason whatsoever. Okay. But here's the thing. Now, on a long enough timeline, we can only really apply probability to an infinite timeline. But on 5 problems, what happens if you guess on all 5? Just kind of probabilistically, if you do that forever, 1 right, 4 wrong. What's your net score? 0. Did you get +1 for your right answer, -1/4 for your 4 wrong answers? 0, right? What's the worst case scenario?
You get negative point somehow.
-1.25 points. What's the best possible scenario?
100.
5 + 5. What are you guaranteed to get if you don't answer? 0. You cannot win if you do not play. Now, this is pure guessing. Now, granted, you could just be unlucky, guess wrong 5 times. But if you can look at those 5 guesses and eliminate one of them, in any multiple choice test, we get really tired of writing 4 wrong answers, so we just write one complete BS answer. If you can eliminate one of the answers and say it's definitely not that one, the odds are now in your favor, and you need to guess. You now have a positive expected value. You need to guess. If you can eliminate 2 answers, if you don't guess, I would flunk you for not guessing. Because that would be part of my probability test. I would say there's a penalty for guessing. It's a -1/4 point on the 5 choice problems. It's -1/3 of a point on the 4 choice problems. If you can eliminate one of the answers, you've got to guess. You just have to. Because the odds are in your favor. Now, why do they do this? Why do they not want you to guess? They frame it like, oh, there's a penalty for guessing. It will hurt your score if you guess. Wrong. They have a product that they are selling to you, and they're trying to protect the integrity of that product because they don't want you going in, randomly guessing 5 times and whoops, looking better at this test than you are. Notice I said better at this test, not smarter, because these tests 100% do not test how smart you are. They test how good you are at taking these bullshit tests.
How good you are at remembering stuff.
Not even remembering stuff. Here's how I know. So when I was younger, just starting off in my career, I taught SAT prep classes to high school students whose parents could afford to send them on a Saturday for 4 hours to do SAT prep for 8 Saturdays. And it was expensive because we don't want poor people to do better on the standardized tests. That's the subtext that I got. And I was specifically there to prep the math portion because there was another 8 days they had to show up to get better at the verbal section. How much math content did I provide those students? 0 is correct. I did not tell people how to do math because if you're doing algebra like you learned in algebra class on the SAT, you got to stop. You are fucking up right now. You're taking too much time. That is not how this test works. If you're doing an arithmetic algorithm to answer the question, you got to stop. That's not what the test is about. The test is about knowing what you're going to be facing on the test. I didn't teach people math. I taught people what the test was like and how to do better at it. And the company's average was you do this class once The next time you take the SAT, your math score will be 50 points higher on average. I didn't teach people math. The test is not measuring how good you are at math. It's how good you are at doing math in this very artificial BS environment. Any questions? Has anybody taken the SAT? A lot of schools are moving away from it because people are realizing this is kind of BS, isn't it? And the college board, the company that makes the test, like, well, no, it's very valuable. Look, all the students that do well on it do well in school. It's like, well, first of all, that's not true. And second of all, those students were doing well in school before because they're well supported, because they come from wealthy families.
And
No, they don't. No one. I like the energy. No one cares about the education. You don't go to Harvard because the calculus at Harvard is like better calculus. I'm not holding back some secret calculus. I'm like, oh, I can't teach them this. This is Harvard calculus. It's better, right? It's not better. You know what you get at Harvard?
Steve,
More than prestige.
Sally,
You meet people.
all connected.
You meet people. The most important thing, well, all you can do, if you're the first person in your family to go to Harvard, all you got to do is get out. You just got to finish. If you're the first person to go to an Ivy League school, you just have to finish. Don't get kicked out. Don't drop out. Just finish. Because then your kids can go to Harvard. They don't have to be as good as you were at school. They get to go. It would help if you leverage that into a big pile of money, then they can definitely go. So either make sure you finish or pull a Zuckerberg, go full on evil villain, get a big pile of money, then your kids will be able to go to Harvard. They could be dumb as posts, by the way, if you have enough money. They could be straight up dumb, bad at school, just gonna get drunk the whole time. It'll be fine. Don't worry. Don't worry. The school will protect them. I always pick on Harvard. Same is true for Yale. Even Stanford. I make fun of all the Ivy League schools. In terms of knowledge for undergrad,
Yeah.
that was a trick question. Because I said for undergrad, no one cares. No one cares about your undergraduate degree. It's not important. Think about my academic qualifications, the ones that I use to get this job. I have a master's degree. I actually got an award in the math department because they didn't see my other work. I'm like, oh, this, you've got an outstanding, I was co-outstanding senior when I got my bachelor's degree. And then when I was talking to the department chair, I'm like, oh, you didn't look at my whole transcript, did you? And they're like, oh, no, why? It's like, oh, never mind. Don't worry about it. Don't worry about it. Just keep doing that.
Just part of the most shiny.
Yeah, just look at the shiny part, the part where I think. But even after I got my master's degree, my master's of science in math, it's not even about the school. Because it would be, Dr. Case, Dr. Keller, Dr. Glass, Mr. Leach. I'm still Mr. Leach, just Mr. Leach. People are all, ooh, he's got a graduate degree. That only works on like undergraduates. Undergraduate degrees only work on like people that are still undergraduates. They haven't graduated yet. Oh, they got their degree. You know what I mean? So the best school to go to is the one that has the environment where you will put the effort in. That's the important thing. If you don't want, I don't even remember where's Notre Dame? Isn't that like in Indiana? If you don't want to live in Indiana for a couple of years, don't go to Notre Dame. I don't care what the school's reputation is. If you like the beach, do not go to Notre Dame. There's not a beach there. You know where there is a beach? San Diego. And it's like sunny and warm a lot of the time. And you're like, oh, but the school's reputation only gets so far. And the school's reputation matters most when it's Harvard, Yale, Stanford, Cal for some reason. Sorry, I had to take a shot at Berkeley. I'm sorry, Berkeley. So, just like real estate, your choice of school, just like real estate, the most important thing, location, location, location. Where are you personally going to thrive? I would hate to be in New York. It would be a disaster if I went to Columbia. That'd be a terrible idea. I don't want to live in New York. It seems like a nightmare. It's dirty. I hate to live there for 4 years. I don't care what kind of school Columbia is. It's a great school, but it's in New York, off the list. Also, I wouldn't get in because I was kind of a fuck up. But that's beside the point. Beside the point. Any questions? The best school is the one that fits with you personally, is what you put into your work. The more you put into your work, the more you will get out of it, the better you will become. So, where do you want to live for a couple of years? That's where you can transfer. Where can you afford to live for a couple of years? That might be an issue as well. Any questions? This is only one person's opinion. Never base anything on just one person's opinion. Things could be different. This is I just try to offer this as a perspective because too many people are like, oh, you gotta go to a UC. Because there's stratification in the UCs as well. We all know that Berkeley is up on top, right? We all know that it's UC Berkeley up here for those of you at home. And then like, what would be next? Where? LA, UC Berkeley, UCLA. So Northern and Southern California are covered. What's next? So we got UC. Those are kind of like interchangeable depending on where you are, which one accepts you. That's what gets on top. After Berkeley and LA, what's next? That is the correct answer. It's all the rest. It's Berkeley, LA, then the rest of them. If you're going to do Vet Tech, Davis is actually above Berkeley and LA, right? If you want to be a veterinarian, that's going to be the top one. But that's it. It's Berkeley and LA, and then there's all the other ones. Was that? Yeah, the rest are just they are UCs, and I hate to say they're just UCs, but they're just UCs. But Harvard, Yale, Stanford, all that shit, those are just schools too. You know what I mean? It's you. What are you going to get out of it? If there's a school that's going to pay your way to go to school, if there's a school saying, you don't have to pay us to come here. Or there's a school that says, we'll pay your living expenses, come to our school, fucking go to that school. They want you there. They care. They're going to work. Don't go begging to get into a school because they're going to treat you like a beggar, which is like crap. So, you know what I mean? You're better than that. All right, that's it for today. I will see you all on tomorrow. Everybody have a good day, and thanks for playing.
Have a nice day.
And thanks for sitting around listening to all my bullshit. Go find other opinions too.